Consider any right-angled triangle. For the non-right angle theta, we define sine theta to be equal to the ratio between the side of the triangle opposite to theta over the hypotenuse. So sine theta is equal to O over H. And then cos of theta is defined to be the side of the triangle adjacent to theta over the hypotenuse H. And then tan of theta is defined to be equal to the side opposite over the side adjacent, so O over A. Can you see another way of writing tan theta? Sine of theta over cos of theta, because O over H divided by A over H is equal to O times H over A times H. And this part cancel out to leave O over A, which is tan theta. Now let's apply Pythagoras' theorem to this triangle. According to the theorem, O squared plus A squared is equal to H squared. If we divide both sides by H squared, we will get O squared plus A squared over H squared is equal to 1. Now this sum here can be written as O squared over H squared plus A squared over H squared. Now, aren't these two familiar? They're ultimately equal to O over H squared plus A over H squared, which is sine theta squared plus cos theta squared. And yes, this is the way you can write sine or cos of theta squared. Therefore, we have the identity sine squared theta plus cos squared theta is equal to 1. Now let's consider a different angle in the same triangle, and let's call it phi. Now, because the side opposite to phi is the one adjacent to theta, the sine of phi would be equal to A over H, and cos of phi is consequently O over H, because the side adjacent to phi is the one opposite to theta. Now, because the sum of the angles of a triangle is equal to 180 degrees, we have theta plus phi is equal to 90 degrees, or pi over 2 radians. Therefore, we have the general rule that sine of an angle is equal to cos of 90 degrees, or pi over 2 radians, minus that angle, and vice versa. Cos of an angle is equal to the sine of 90 degrees minus that angle. These rules are not in the data booklet, but you can easily verify them using a calculator. Now let's consider a circle on the coordinate axis with its center on the origin and a radius of 1 unit. Let's draw a line segment from the center of the circle to a point somewhere on the circumference of the circle. And let's call the point where they meet A. Now I will draw these dashed line segments perpendicular to the axis. And let's call this point B. Let's also call the counterclockwise angle that OA makes with the positive x-axis theta. Now from the definition of sine theta would be equal to AB over OA. And cos theta is equal to OB over OA. Here OA is technically the radius of the circle, therefore its length is equal to 1. And thus sine theta here is effectively equal to AB and cos theta equal to OB. We can conclude that cos theta is the x-coordinate of A and sine theta is the y-coordinate of A. Therefore, the point A can be represented like this. As we change the value of theta, sine theta and cos theta will change according to where the point A is on the unit circle. Now let's reflect our line segment OA on the y-axis to create a new segment. I'm going to call this point A dash and this point B dash. And the new angle that we have created, I will call it phi. Recall that we take this angle to be the counterclockwise angle from the positive x-axis. So phi is an obtuse angle and not the acute angle here. Notice that by reflecting OA, we have made two congruent triangles with all sides and angles equal. Therefore, this acute angle here is also equal to theta. You can see from this diagram that phi and theta are supplementary angles. Now, sine of phi is equal to sine of theta because the points A dash and A have the same y coordinates. But cos of phi, although equal to cos of theta in magnitude, is not equal to cos theta. This is because the point B dash is on the negative x-axis, while B is on the positive x-axis. Therefore, cos of theta would be equal to the negative of cos of phi. From this, we have obtained the general rule that the sine of an angle is the same as sine of the angle supplementary to it. And cos of an angle is the negative to cos of the angle supplementary to it. This time, let's reflect OA on the x-axis. And this will be our angle phi. Phi is now between 270 degrees and 360 degrees. Or you can also say that phi is between minus 90 degrees and 0. Because we are taking positive angles to be in the counterclockwise direction, negative angles are just in the clockwise direction. This time, phi is equal to 360 degrees minus theta. Again, we have two congruent triangles, so this angle is also equal in magnitude to theta. Cos of phi is now equal to cos of theta. because the points A dash and A have the same x coordinates. But now, sine of phi is the negative of sine theta, because as you may have guessed, the y coordinate of A dash is now the negative of A's y coordinate. This case gives us the general rule that cos of an angle is the same as cos of 360 degrees minus that angle. And sine of an angle is the negative of sine 360 degrees minus that angle. We've talked about angles with the same sine and cosine. Now what about tan? Where on this circle would the angle phi give the same tan value as theta? Because tan of an angle is equal to sine of that angle divided by cos of that angle. We should look for cases where sine theta over cos theta is equal to sine phi over cos phi. So first, let's look for a case where both the sine and cosine values for theta and phi are the same. However, we have just shown that if the sine values of two distinct angles are equal, then their cos values are negatives and vice versa. Therefore, this case is rejected. So what can we look for to fulfill this condition? If both sine phi and cos phi are negatives of sine theta and cos theta, then when we divide sine phi by cos phi, the negative signs will cancel out, giving us an answer equal to tan theta. Is there a point on this circle for phi where both of these conditions are satisfied? The answer is when we rotate OA by 180 degrees in either direction. Phi is now equal to theta plus or minus 180 degrees. Now both the x and y coordinates of the point A dash are negatives of those of point A. Therefore, sine of phi is negative sine theta, and cos of phi is negative cos theta, exactly what we wanted. And therefore we have the general rule that tan of an angle is equal to tan of 180 degrees plus or minus that angle. To recap, in this video we've covered the definitions of sine, cosine, and tan in a right angle triangle. We've also looked at the relationship between sine and cosine for complementary angles. Then, with the help of the unit circle, we've looked at cases where the values of sine, cos, and tan of two distinct angles could be equal. Lastly, we've covered the Pythagorean identity and the identity for tan. Thanks for watching.